I am application developer here at ThoughtWorks. With me is Venki. She is also a developer here at ThoughtWorks. So we are working on a small prototype, a small project, which we named it as H2O. It's the smart water dispenser. It was done in a small hackathon, 24-hour hackathon, and we rebuilt it just yesterday. So it took us close to like 4 hours, and we were able to integrate this app. So we'll start with it. So what is H2O? No, this is not this. That was from a previous project. This is H2O. So H2O is an internet connected water dispenser which can identify you from your ID card. It measures the amount of water you draw from it and then it posts it to the server. Very simple application. Instead of you having the smart water bottles and then putting it at all sort of taps and then doing this, there is this one smart water dispenser we have. You go there, tap your ID card and it start taking in water and it posts that to your Fitbit and wherever you want your water to be, you want to see how much water you have. So this is the small application which we thought of doing it. Okay, so we'll start how we build it. Good. So we'll start with the hardware part. The first part is there is an Arduino. So Arduino is the heart of the project where we are measuring the amount of water, where we are interfacing with the ID card, where we are interfacing with lots of LEDs for indicators and so on. How does a basic Arduino program looks like? It's a very simple program. You say setup, where you set the mode of the pin. There are like 13 pins here and like 5 pins, 6 pins here. So out of this 18 pins, you can see set mode of the pin. You want it as an output or an input. Then you can write its value as high or low, and then it would blink an LED. It's a very simple program. Probably I can demonstrate that to you. It won't take more than 2 minutes. You can actually start counting. So I have my Arduino connected with my laptop. Uh, I go to File, I go to Examples, I go to Basics, Basic link. This is the code, exactly the same code. I didn't select the board. I have to select my board, which is Arduino Uno. I need to select the port on which it is connected, and then I say cool. It is uploaded, and you see LED blinking. That's it. Nothing much. Okay, a fifth grader kid can do. So you can also obviously. So if you want to confirm, I change the frequency, and this is done. It blinks fast. Right? So as simple as that. Nothing much. That was the first part. Let's go back to the presentation. So sorry. Okay. What is it? Okay. So, yeah. So we did the first program, blink LED. Next is you want to become Sherlock. You want to identify who is the person who is around the smart water dispenser. So this is something which is very common. Okay, I think most of those who are working in any corporate here might have seen this kind of HD card. But if you have been curious enough, I mean, like you could just open it up and then you would find these many wires inside this. And out of this, to interface to an Arduino, you just need 4 wires: VCC, ground, and 2 data wires. There is already pre-written code for it. Just Google up how to interface HID reader with Arduino, and then you will get a link called PageMac uh, interface Arduino, sorry, this is very simple project. You get all the code. I'll copy the entire code. I'll burn this. I'll connect exactly what this guy says, and then I'll show you how it reads your card. Give me a minute. Go back to my Arduino. I open recent, which is I get this copy. This copy. Okay, cool. And I have to connect this to this guy. 2 minutes holds. We connect VCC to VCC. We connect ground to the ground. Then it says connect red wire to 5 volt, connect black wire to ground. Then it says connect green wire to the digital pin number 2. Then it says connect white wire to digital pin number 3. And I'm done. I connect it back. Oops. Not this one. And I upload this program. Thank you. That's what we have to do first. Compile the program and then okay. So the program is uploaded. I open my serial terminal and hopefully this will work. So if the RFID reader is connected, probably I tap it. It's unable to decode. It's what is my baud rate? Uh, this is not able to decode, so probably we need to debug the code. Okay, I did not connect it to the proper place. Okay, it got the value. So it has got the internal number. It is not properly focused, but still you can say that it gives out you the card code which is there for this ID. If you read another card, maybe this one, this is not having the HID card, the internal card. This is not the HID one. This one. Yes. So it is giving the another card which is mapped to arrow. Okay. So we are able to interface it with the ID card reader. We become the Sherlock Holmes of electronics. Cool. Awesome. Let's go back to our presentation. Next thing is the capacitive touch switch. Yep. See, it is written here. So, okay, the card code you are talking about. Okay. So the card code, it is embedded by the manufacturer. So you don't write to that card code. You purchase those cards and you get those cards. So it is very less likely that you would find another card with the same code. As far as my knowledge, I could be wrong also. But mostly which I have seen is you get the card, you just see what code is it, then you map it with the employee ID.
I was just curious how easy it is to spoof a card.
There are ways. There are ways.
There are always ways.
There are always ways. Next is the capacitor switch. I won't demonstrate this. There is a small video about this capacitor switch. It's very easy to. There is already a library, capacitor switch library. You just connect it with a metal piece. You one resistance in between and connect two wires, and then it works as a capacitor switch. So it's a very simple circuit diagram that they built. We uploaded the code, and this is the values it returns. See, so you just copy the code, burn this, add those connections, very simple, and then you get those capacitive buttons. That's it. So let's go back. The last part is how do you connect it to the internet. For that, I am using something called as Node MCU. Node MCU, this board is the cheapest alternative which is available today. This costs me some 350. So 350 rupees, not dollars. So fairly cheap. Then it can connect to my internet, which is I have here. I can connect it to TW event. I can connect to whichever network I want. Uh, for now, I didn't find a library where I can connect it to a corporate network with the ID and password. But still, I need where you enter your employee ID and your AD/IDs and password. But I'm still able to connect it to like what you connect with your phone to TW event, which you connect it to. So here is a small program on this. It's better I'll show you on this. So this basic program, what it does is, I would make a request to this particular URL, any URL, and it would return me a response. There are some, it's a program for my custom requirement where I had to show that it is connected to internet. Then I would blink an LED. There's an RGB LED. There's a buzzer also connected. So for that there are a lot of digital rights, pin modes and all those stuff. But I'll use this program and I'll show you how easy it is to add Wi-Fi connectivity to the project. Okay, let's connect this. Uh, there was another program. Okay, I'll go back. See, it reminds me to drink water. Cool. So this program, I'll be connecting it to my board. Here, in this case, the board is Node MCU. The board on which it is this one, and it's a simple code. You would get a lot of sample codes for this also. So there are codes which are for HTTP client. You can scan for what all Wi-Fi networks are there. Then you can connect to those. You can start set it up as a Wi-Fi server where this acts as a server. It will give you the IP. Open it from your mobile, that link, and then you can turn on and off. So you can set up a internet. So there are some example codes. Considering interest of time, I'll just burn up this code. What this code does is it reads for a serial available. So I'll be connecting it to the serial console of my computer, and then I will be sending it a URL. That URL it has to post, so it has to make that server call, and it has to print the JSON response which comes back. So this is the intention of this program. There is a very good uh, free API available. It is called as freegeoip.net. So what it does is you just open this link and it will give you the JSON of uh, where is this server located. I'll just say what is my IP address. It gives me my IP address. So if you go to freegeoip.net and paste your IP address, it gives you a JSON response of where you are, India, Tamil Nadu, Vishnu, but that also the latitude longitude, which is probably the ISP. It might not be accurate to surface. Still, so we have this very good API available. The URL is this. We are going to make a call. Oh, I don't paste it. So I did it. Probably is. You can see it here. Okay. Okay. So it is connected. I paste the URL. I send the request. Okay. I got this response back. So it says I'm in India and in Tamil Nadu and it gives up the response. Right?
I don't understand. So you paste the URL from browser.
No, I didn't paste it from browser. I paste it from the serial terminal. So serial terminal is something which enables the communication between computer and this. It opens it as a serial port. If you see, I have opened it as a port here. So this is connected to this device. And to connecting to this device, I open a serial monitor. In the serial monitor, it will start communicating with this device. So in my program, what I'm doing is I'm reading what is available on serial data. I'm making a string out of making a get URL, and then I'm doing a get request http.get. So when I do this, I am able to get the response. Very simple. So in my application, water dispenser, I have set up a server. On that server, I am making a request with the card number and the amount of water which is dispensed. Okay, and then I'm forming a URL and then I'm sending this to the server. So this is what. So we are going good. Any questions till yet?
Yeah, I think I might understand.
I think I'm very fast. Sorry. Yeah.
How exactly are you calculating how much water?
That's a good question. So this is the problem we face in the hackathon itself. So what we are earlier trying to do is have a flow sensor where we would measure the speed of water. But we tried a very simple experiment. We thought let's fill it completely, your water dispenser with 20-liter cap. Then let's count the time it takes to dispense the first liter. Then we'll count the time to take second liter, third liter, fourth liter, fifth liter, 20th liter. We assume that the time would take increase. The time it would take, it would increase because the water level it would come down and the force would increase. But to our happiness, I could say, it was linear, flat linear. Only from 20th liter to 21st liter, which is the amount of water which is stored internally in the dispenser, for that it was very slow. But for all those liters, till the last drop which is there inside the can, it was fairly safe. 33 seconds for a liter of water. Okay, so next time you are around the water, you can just count please 33 and your water will 1 liter water will be.
Dispenser is not a tap type dispenser.
Dispenser is not a tap type dispenser.
Only one speed at which the water flows out.
Yes, or maybe so generally you won't push it like 10% and wait for 330 times, like 330 seconds.
Normally,
Yeah. Generally, you would want to take it with the high. So we are good with the happy case scenario. Okay. Even if it's like I want 1 liter and it is showing 998 ml, I'm not that concerned with that, right?
Does it work for both hot water and cold water?
Yes. So what we have done is you have shown those capacitive switches, right? So that capacitive switch we have put it on the tap. That's it. So we don't need to open the water dispenser and put something inside it. We see there's a button or maybe there's a, knob. We put our that tin foil on it and then you just press it. We don't think that people would be dishonest, that they would just touch it and then they would increase their water intake. It is for their benefit. So yeah, this is one way they can cheat, but it's up to them whom they're cheating. Good. So this is fine. Next comes the software backend. Uh, yeah. You share your IP address and open this here. What's the port number? 1003. Yes. No, I'm on this.
The server side we have used Node.js and MongoDB to store the data, and in client side we have used Angular Vue. So in the server side we have stored all the user data. So whenever the user using the access card, they use access card, and after that they will take the water, and the IoT device will do a HTTP request to our server, and we will store it. And this is the client that user will do by entering our employee ID. Uh, we will display how much water in a particular day a person has consumed.
So the backend, yeah.
It's very simple actually. The backend is the Node.js and the MongoDB. The front end, what user is seeing is the Angular.
What's the backend URL? So, so we created a sample application where we have also had the uh, admin console. So we used to get. Do you have the Excel sheet? Yes, you do. So from the access control department, we can export all the data to the Excel sheet. If you see the Excel sheet, it would be to the access control. So if you see the access card details, it lists your employee ID, employee name, card ID, sign code, status, and department, and also it lists the name, employee name. Yeah. So with this data, we were able to populate. So our backend application had the admin console where we can upload a file, the Excel file, so that all that data gets populated into MongoDB. We wrote a service backend where we would fetch who is the person who is associated with that card, and then we would also add those volume into his particular table. So and at the end of the day, when he requests for it, we just show him what how much water is consumed by him. So if I enter my employee ID, if it exists, I have consumed zero. I did this. Okay. So yes, so this is how the application works. This is the front end part of the application, and the hardware part in this you guys have seen. So so there is a small video of this demonstration. Uh, So if you see there is something, this is the hardware diagram, how it is integrated. Maybe I don't think we have a lot of time to cover this, but I'll share the slide details so that we can have a deeper look at that. So I'll just quickly brush up through the code. What exactly is this code? What exactly is going in the Arduino? So what happens is your card reader, it is connected to some on Arduino to something called as interrupt. What this interrupt does is whenever a card is swiped, my program counter jumps to the function where my interrupts are defined. So here to the interrupts, what it is finding out is, I'm sorry. So what here it is finding out the count value, the card number, and then once it gets the card, it calls this method print bits. So no matter where are you in the application, whatever the Arduino is doing, you whenever you swipe the card, it goes to the function print bits definitely. Once you are in that function, it will blink up that dispenser LED, which is red color, so you know that your card is registered. Then you call this function get volume. What this get volume does is it will wait for your button to be pressed, the dispenser button or dispenser tab to be pressed. Once it is pressed, it will wait for like 500 milliseconds to confirm that the button is really pressed. Okay, not like somebody press it and then release it. It waits for half a second so that somebody has pressed it and he is keeping on pressing it. Then it starts counting. It starts the timer. Once the button is released, then he stops. Then we stop the timer. We stop the timer and then we count the time, how much time was in between those stop millis and the start millis. Then there's a map function in the Arduino which you can map it like 0 to 99 would be mapped to 0 to 1000. So your time count, so in seconds we assume that you won't be standing there uh, filling more than 3 liters of water. So 0 to 99 second would be mapped to 0 to 3 liters. That is it. It returns the volume. Once it is returning the volume, it is making get. It is just calling this serial println to this URL. What this URL is? This URL is connected to my node MCU, the program which I showed you before. And once you make a call to that, it does the another job of handling sending it to the server. So that part is completely abstracted. It makes my program more modular, it makes my hardware modular so that tomorrow I need to connect it to my weighing machine. I just need to send the weighing related data. I just need to send the URL where is my server, and my node MCU, my the other piece of hardware remains the same because it's just accepting the serial data and it is just taking the network calls. So this is how I abstracted these two, and yeah, we are able to make the applications very quickly. So this was the final code. I think we are good with this. There's a video of it. It's not loading on this, so I'll show it here. So you take a card, you swipe it, the light color changes, means it is registered your card. You start taking in water, another light changes.
Where is that chip?
Once it is done, you see it here, it increases. So, yeah, this is the instruction.
Ink file.
So, okay. So this was the project which we did it in the Pune office. There we did come up with this tinfoil approach. So in that one, this is the second revision which we have done here. So in that one, we actually opened up uh, what the water dispenser, and we placed a blade on the top of that button. Okay, so that blade would then fall off on a wire, and then it would make a contact. So for the user, it doesn't look like something is happening, but uh, it is all the interface behind the scenes. So yeah, it was a quick way for implementing in a hackathon that we did. So yeah, any other questions?
Yeah. So how do you can you wire up this Arduino and Raspberry Pi so that you don't need that node
Okay.
MCU?
The cost of Raspberry Pi is some 3,250.
No, is it possible?
Yeah, 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 definitely. But then why do you need a Arduino then? You can directly read those values on the Raspberry Pi itself. Raspberry Pi has the GPIO ports
Okay, so everything can be done
on the
using Raspberry Pi.
Raspberry Pi itself.
Okay.
But then it's a costly solution, and this I could manage in 800 the hardware. This thing, HID reader, is a very costly device. It costs some 5,500. I think we are happy that we got it very easily here in the office. But yeah, any questions? Did you like it? Thank you. There's a demonstration. I hope it works. We'll try that.